This video demonstrates a system to create nonlinear projections of geometry and shading within a conventional computer graphics pipeline. An animator interacts with the scene with the usual linear perspective camera, which we call the boss camera. The animator then introduces additional linear perspective cameras, which we call lackey cameras, to define alternate views of the scene. A lackey camera, as shown here, can be interactively manipulated through the lens or externally through a global view of the scene containing both the boss and lackey cameras. Here we see a lackey camera interactively act as an aperture stop along the boss camera's optical axis to model the barrel distortion seen in wide-angle lens systems. When retargeting projections from one camera's point of view to another, the geometry moves in image space. To maintain global scene coherence, we introduce scene constraints. Here we see the position of a pillar being constrained in space, as its projective properties are animated from those of the boss camera view to those of a lackey camera. This animation test from the film Ryan, currently in production, demonstrates the creative power of the approach. By deforming geometry to appear as though seen from multiple points of view, an animator can easily construct and play back shots such as this at an interactive rate. Traditional illumination models do not apply well to nonlinear projections defined by weighted linear perspectives. In this automotive visualization, changing shadows and illumination distract from the projective emphasis of selected regions. To maintain rendering coherence during animated projections, we render the scene as a weighted blend of the illumination models for all cameras. Shadows of deformed geometry, such as the table in this animation of the Ryan cafeteria set in which the walls, tables, columns, and ductwork are seen from different nonlinear perspectives, can detract from the intended perspective effect. This shot incorporates shadowing with respect to the original geometry. We now have a temporally coherent ground shadow cast by the table.